Okay, so here we have some questions that ask us to solve for x. So this is similar to an exponential function. If you are solving for x in an exponential function, we would get one power on the left, one on the right. And once we had the same power, then we would know that we could get rid of the base and just solve for the exponent. So for example, let's say we had 3 to the x equals 27. We would make sure that we had the same base on each side. So we would change 27 to 3 to the power 3. And once we had base 3 on the left was the same as base 3 on the right, we didn't really need the base anymore. We knew that the exponents must be equal. So it's the same with logs. Okay, if we can get one log on the left and one on the right with the same base, then we can say that the argument or the answer is the same. So here's the first one. We have log base 2 of x, log base 2 of 5, plus log base 2 of 10. So on the right side, we have two logs that are added together, and they have the same base. So we can combine those two logs. So we can change addition to multiplication. So we'll do 5 times 10 so that we can combine those two logs. So now we have, oh, I'm missing my x here. Now we have 1 log base 2 on the left. We have log base 2 on the right. Therefore, x must equal 50 for those two logs to be equal. Okay, so it's exactly the same as exponential functions. Once you have the same base, you can ignore the log part and just look at the argument. Okay, so let's see what b is. Log base 3 of x equals okay, so on the right we have two logs that we want to combine. It is subtraction. So we can convert subtraction to division. So we'll do 18 divided by 3. And once we have that, we have 1 log base 3 on the left, 1 log base 3 on the right. Therefore, x must equal 6. So we're just combining using our log laws to do that. Let's do one more. So we'll do d. You'll notice in d that there's no base, so that is assumed that it's base 10, right? Because we don't have a number there. So order of operations says you have to do exponents first. So these numbers at the front need to go back up as a power. So we're going to put the 2 back up, so it's 4 squared. And then we're going to put the 3 back up, so that it's 3 to the power 3. So remember, it's to the power, not multiplication. So that's 16 and 27. And then once we've done that, we can change addition to multiplication. So we'll do 16 times 27 so that we have 1 log. Somebody's got their mic on. So I'm just going to grab my calculator. And we get 432. Oops. So once we have that same log on both sides, then we know x equals 432. Okay, so you're just taking your log laws, combining them together, and then you can solve for x. Another type of question is where they want you to take these logs apart. So this question says write the expression in terms of logs of x, y, and z. So that means it wants you to take them all apart. So we want to reverse those log laws. Okay, so we have log x squared y. So the first thing we would do, we can't bring any exponents down first. We want to separate the multiplication. So we're going to change multiplication to addition. Okay, So x squared times y is going to be log x squared plus log y. Then once we have them separated, we can bring down any exponents. All exponents need to come back down. So it'll be 2 log x plus log y. So that's all you're doing. You're just separating them, taking them apart, and writing them as individual logs. So let's go over to number 3. So some are a little more trickier than others. So we've got log, some of them will have roots in them. So we've got root x, third root y squared over z to the fourth. Okay, so I am going to take apart the multiplication in the numerator. So the log root x and the log third root y squared, we're going to change that multiplication to addition. And then the z to the fourth is going to be changed to subtraction. Okay, so multiplication and division I'm going to separate. Once we've done that, we have to bring powers down. So I need to write them as an exponent. So root x is the same as x to the 1/2. This one would be 2 over 3. 3 is the root, so that's the number that goes on the bottom, and 2 is the power, so that's the number that goes on the top. Okay, so I'm going to express them as exponents, and then all these powers need to come down to be finished. Okay, so separate the multiplication and division to addition, subtraction, and then change any roots to exponents, and then bring those exponents down. All right, let's look at, let's try another one. So I'll give you one to try. Let's try, actually, let's do number 6, because it's brackets. Then I'll get you to try one. So this one's different because there's brackets around the x and the y. That means that the power 2 belongs to both the x and the y. So I might apply that power to the x and the y first before I separate. And I'll show you the difference. You can do it the other way as well, but let's do it this way. So I've applied the power 2 to the x, the power 2 to the y, then I'm going to separate division to subtraction, and then I'm going to bring down the exponents. Oops, I need a 2 there. Okay, so that's one way to do it. Apply the power to the x and y, then separate and bring down the power. Or you can bring down the 2, right? You could apply the power law first. So we'll bring down the 2. Then we'll separate. But we have to remember that that 2 applies to both terms in the bracket, so then we would have to expand by multiplying each term by 2. Okay, so it's your choice which way you do it. Bring down the exponent, separate, and then multiply, or apply the exponent, then separate, and bring down the 2. You just have to remember that if you do it the second way, you have to multiply both terms by the 2. So it might be easier to apply the exponent first, and that way you don't forget to multiply both terms by 2. Okay, I'm going to get you to try one. Let's try 10. So you can write this question down. Let's see. Okay, so it's log fourth root of x3, y2 over z to the 4. Let's see, make sure I get that right. Yep. So why don't we try that one? I'm just going to do the attendance. All right, let's see what we get. So the first thing you probably want to do is change that root 4 to an exponent of 1/4. Okay, I prefer to, you can bring down the 1/4 now if you want. I prefer to just apply it right away. So all these variables are going to be multiplied by 1/4. So it'll be x to the 3/4, y to the 1/2, right, 2/4, and z will be to the power 1, right, because 4 times 1/4 is 1. Once I've done that, I will separate multiplication to addition and subtract, or division to subtraction. And then the final step is to bring down those powers. There we go, easy peasy. Okay, so that's a typical question, is using your log laws to take expressions apart, and then we looked at earlier where we were putting them together so that we're able to solve. Okay, are there any questions on the laws of logs?